What color is an apple? Most people would answer without hesitation, red. It seems so obvious, so certain, that the apple is red, just as the sky is blue or the grass is green. But here's the twist. The apple itself has no color at all. Its surface is simply a complex arrangement of molecules that reflect certain wavelengths of light and absorb others. When white light from the sun or a lamp hits the apple, the skin absorbs most of the blues and greens, while the longer wavelengths, what we call red, bounce off and scatter. These reflected waves are actually invisible electromagnetic radiation, traveling through the air at the speed of light. They have no color of their own, just energy and frequency. Some of these waves enter your eye, passing through the lens and striking the retina at the back, where the magic of perception begins. The retina is lined with millions of cone cells, each tuned to detect different ranges of wavelengths: red, green, and blue. These cells are the biological sensors that make color vision possible. When the long red wavelengths hit your red cones, they trigger a tiny electrochemical impulse, a spark of information that signals red to your brain. This signal travels down the optic nerve, a superhighway of information, all the way to your brain's visual cortex at the back of your head. There, billions of neurons work together, processing the signal, comparing it to signals from other cones, and even consulting your memories and expectations. After all this intricate processing, your brain creates the vivid sensation of red, a mental experience, not a property of the apple itself. The redness you see isn't in the apple at all. It's a private internal show, an illusion conjured by your mind. The apple is just the trigger, the starting point for this internal masterpiece of color and perception. So, when you gaze at a red apple, you're not simply observing reality as it is. You're actively constructing it, painting the world with your own mind's brush. Your brain is a master storyteller, weaving together signals, memories, and expectations. Color is one of its most compelling and convincing narratives. The universe outside your mind is, in truth, colorless, soundless, and odorless, a silent gray stage waiting for your brain to bring it to life. Your brain dresses this blank reality in vibrant colors, rich sounds, and evocative smells, transforming the ordinary into the extraordinary. The red of the apple is a gift from your mind, a vivid creation that makes the world feel alive and meaningful. It's your brain's vivid translation of a silent, physical world, turning invisible waves into a feast for your senses. Without your brain, the apple's redness would vanish. The world would be stripped of color, left only with energy and matter. So next time you see a red apple, remember, you're not just seeing a fruit, you're witnessing your brain's art in action. Color isn't out there in the world, it's in here, within the theater of your mind. To understand how your brain builds color, we need to start with the very basics of light itself, what it is, and how it interacts with the world around us. Light is a form of energy, and it's all around us, whether it's coming from the sun, a lamp, or even your phone screen. Visible light is just a tiny slice of the electromagnetic spectrum, a vast range from radio waves to gamma rays, most of which we can't see at all. Imagine the spectrum as a giant piano keyboard stretching far beyond what you can play. The visible part is just a single octave, a small but vibrant section. The rainbow we see is this narrow band, with each color corresponding to a different wavelength of light, blending smoothly from one to the next. Red has the longest wavelength in the visible spectrum, while violet has the shortest. Each color in between has its own unique wavelength. When you see a rainbow or light passing through a prism, you're witnessing sunlight split into its constituent wavelengths, revealing the hidden spectrum within white light. Our eyes evolved to detect this range because our sun emits most of its energy here, and these wavelengths travel especially well through both air and water, crucial for life on Earth. Our cone cells are tuned to this slice of reality, each type sensitive to different parts of the visible spectrum, allowing us to perceive a rich palette of colors, but we're blind to the rest. Radio waves, microwaves, X-rays, and more pass through us unnoticed, invisible to our senses. The light that hits an object is a mix of many wavelengths, a blend of invisible and visible energies. The object's surface acts like a filter, reflecting some wavelengths, absorbing others, and sometimes even scattering light in different directions. A blue shirt, for example, reflects blue wavelengths back to your eyes, while absorbing most of the rest. A yellow lemon reflects a mix of red and green, which your brain combines to create the sensation of yellow. Your brain receives this recipe of light, mixing the ingredients of different wavelengths, and interprets it as color. A unique experience for each observer. The object itself isn't colored, it's just reflecting certain wavelengths. Without light, or without a brain to interpret it, color simply doesn't exist. Your brain is the chef, cooking up the experience of color from raw ingredients, turning invisible energy into a vivid personal reality. Color is not a property of objects, but a creation of your mind, a mental painting made from the language of light. Every color you see is a translation, not a fact, a secret language your brain speaks, turning the invisible into the beautiful world you experience. For centuries, people believed that colors mix just like paint. Combine blue and yellow and you get green, mix red and blue and you get purple. This simple idea shaped how artists and scientists thought about color for generations. But Isaac Newton shattered this idea in the 17th century. He showed that white light, when passed through a prism, splits into a vibrant rainbow of colors. And remarkably, those colors can be recombined to make white light again. Newton took this discovery further by arranging the spectrum into a circle, connecting the ends, red and violet, to form the very first color wheel, a tool that would change how we understand color relationships. This circular model revealed how colors relate to each other. Opposites on the wheel are complementary, while neighboring colors blend smoothly into one another, creating endless possibilities. But Newton's circle contained a curious puzzle: purple. Unlike other colors, purple didn't fit neatly into the spectrum. There's no single wavelength for purple in the spectrum. If you look at a rainbow, you'll notice purple is missing. There's only violet at one end. Purple is what your brain invents when both red and blue cones in your eyes are stimulated together, but not the green ones. It's a unique blend, created entirely by your mind. In other words, purple is a color with no physical counterpart in the world, a vivid creation of the mind, existing only in our perception. This reveals something profound. Perception isn't a direct mapping of reality. Our senses interpret, filter, and even invent what we experience. Your brain fills in gaps, inventing colors like purple to make sense of incomplete information, ensuring your experience of the world feels whole and continuous. Some colors we see are not just reflections of light, but inventions of the mind, evidence of the brain's remarkable creativity. Newton's circle didn't just map out the physics of light, it highlighted the creative power of the brain to shape our experience of color. The existence of purple shows that our experience of color is, in many ways, a beautiful fiction, a story our minds tell us. Our brains are not passive recorders of the world, they're active interpreters, constantly constructing and coloring our reality. The color wheel is more than a map of physics. It's a map of perception, showing how our minds organize and invent color. Some colors are real only in our minds, existing nowhere else in the universe but in our unique human experience. The world you see is partly your brain's invention, shaped by both light and imagination. Color is as much about imagination as it is about light, a vivid reminder that reality is shaped by the mind as much as by the world outside. Newton's color circle was just the beginning. Color isn't flat, it's a three-dimensional space. To describe any color, you need hue, saturation, and brightness. Hue is the basic color, red, blue, green, determined by wavelength. Saturation is intensity, a vivid pink versus a dusty rose. Highly saturated colors are pure, less saturated ones are muted. Brightness is how light or dark a color is. Maroon, crimson, and scarlet are all reds, but differ in brightness. Every color you've seen can be located in this three-dimensional space. Hue gives color its name, saturation its vividness, brightness its lightness or darkness. These three axes define the universe of color your brain can create. Artists and scientists use this model to mix and describe colors precisely. The world of color is richer than a simple wheel. It's a full spectrum of possibilities. Your perception of color is built from these three simple ingredients. Every shade you see is a unique point in the space. Why do we see in color? Evolution shaped our vision for survival. Our primate ancestors needed to spot ripe fruit among green leaves. Our three-cone system is tuned to the colors of fruit and foliage. This ability gave us an edge in finding food. Our brains are wired to detect things that break the natural pattern, like a red berry in green leaves. But our vision is specialized, great for daylight, less so for darkness or subtle blues. Our perception is a biased, edited version of reality. tailored for survival. We see what helped our ancestors thrive. We assume our color vision is universal, but animals see the world differently. Most mammals, like dogs and deer, are dichromats, red-green colorblind. To them, a tiger's orange coat blends into the grass, making it perfect camouflage. Camouflage only makes sense in the eyes of the observer. Some animals, like birds and bees, are tetrachromats. They see ultraviolet. Flowers that look plain to us have UV patterns guiding bees to nectar. Each species lives in its own sensory world. Our rainbow is just one version of reality. The colors we see are tailored for our needs, not universal truths. Every creature's brain builds a model of the world that helps it survive. Our colors are just one way to see the world. Some humans may see more colors than the rest of us. Women with 2 X chromosomes can inherit 4 types of cone cells, tetrachromacy. Tetrachromats might see up to 100 million colors compared to our 1 million. A sunset or a rainbow could be a far richer experience for them. They see distinctions in color we can't even imagine. Their perception is like hearing extra notes in music. There are colors in the world most of us are blind to. Our reality is limited by our biology. If color is a brain construction, can we create impossible colors? Yes, scientists have made people perceive colors like reddish-green using special experiments. By showing each eye a different color, the brain tries to merge them, creating a new, unfamiliar color. These colors don't exist in nature. They're artifacts of neural processing. After images or another trick, stare at green, then look away, and you'll see magenta. Your brain invents this color to balance out tired cone cells. These illusions reveal how color is a negotiation between neural signals. By pushing the system, we glimpse how the brain builds our visual world. Impossible colors show the flexibility and limits of perception. The palette of our mind is broader than reality itself. We started with a red apple and uncovered a profound truth. The colorful world you see is not the world as it is. It's your brain's creation. Color is not in the universe, it's in us. Your red is not my red. We can never be sure they're the same. Every time you open your eyes, you create a spectacle from colorless energy. This is not deception, but translation, an interface for survival. We are not passive observers, but active creators of our experience. The laws of physics provide the raw material. Our brains provide the artistry. This is true for all senses: sound, smell, taste. Appreciate the colors you see as gifts from your mind. Try to imagine a new color. You can't, because your brain is the limit. The universe of experience is not discovered, it's built. Your world is your masterpiece.